Hi there, folks. Today we're looking at slope-intercept form, all right? This is the third form of the equation that we're going to use for lines and graph them. The first one was standard form. That's when we did our cover-up method, just doing the x and the y intercepts. The next one was point slope form. That's when we finally started graphing using the slope, where we would start with a certain point, and it would be any point on the graph, and then we'd use the slope as the pattern to get to the next point. Well, slope-intercept form, we're going to graph pretty much the same way as point slope, but instead of starting with any point, we're going to start with a specific point on the graph every time, and that specific point is going to be the y-intercept every time. So point slope, we started with a point somewhere on the line and used the pattern of the slope to graph the next point. With slope-intercept, we're just going to start with the y-intercept as our point, but then we're going to do the same thing. We're going to use the pattern that the slope gives us to get to the next point and the next point. Okay, slope-intercept form is of the form y equals mx plus b. This is the one that most students remember. M is still the slope, but now the b value, that's our y-intercept. And keep in mind, we'll always write that as an ordered pair. This would actually be the ordered pair 0, comma b. All right, whatever that value happens to be. And really, the reason that works is because just the general format here, you can imagine that if you plugged in a 0 for x, if I plugged in a 0 here for x, it doesn't matter what m is, this thing would cancel out and I would just get y equals the b value. So when you think about finding the y-intercept, it's when I plug a 0 in for x. It just so happens that in this format, when I plug a 0 in for x, the y value always equals whatever that number at the end is. Okay, and so really it just makes a very nice, quick way to graph things. We could still do an XY chart, find a point, and then use the slope to graph from there, that kind of stuff. So all of those other methods still work. We could still find a point and use the slope from there, or we could do an XY chart and plot a bunch of points, all right? Or we could find the x and the y intercepts by plugging zeros in for x and zeros in for y to find each of those. But really, it's just when we recognize this form of the equation, the fastest and easiest way to graph is using the slope and the y-intercept, okay? For example, if I look at something like this guy, this is in that format y equals mx plus b. So like right here, m is the 2, and b is the -1, but write this as an ordered pair for the y-intercept. So now the y-intercept would be the ordered pair 0, -1. And of course, the slope I would probably write as 2 over 1. So now it's just like what we did when we were using point slope form. I have a point and I have the slope. So I start with that point, 0, -1. And then I have the slope. The pattern that it's giving me is up 2 over 1. Up 2 over 1, up 2 over 1. Or if I went backwards, it would be down 2, back 1. Okay? And now I plotted a bunch of points and I graphed the line. And again, you really technically only need 2 points, but use that pattern to graph a bunch and your graph will be more accurate. And it's good practice kind of using that pattern. Okay? If I look at the next one, same kind of thing. The slope this time is a -3, which I'm going to put over 1. The b value this time is a 7. All right, so there's m, there's b. It's just the numbers I see. But then write that as an ordered pair. That's the ordered pair 0, 7. Okay, so now I plot the point, 0, 7. And then I use the slope. The pattern that's being described here is down 3 over 1. So down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. And now I graph my line. It's the same thing that we did with point slope form, except I happen to be starting at the y-intercept as my point every time, okay? If I look at the next one, again, so this one, the slope is a 1/4. And now instead of writing down b, hopefully we can all see that the b value is a -2. So let's go right to writing as an ordered pair. That's 0, -2, okay? And so now it kind of looks even more like point slope, where we write down the point and we write down the slope, and now I'm going to graph the thing. 0, -2 is right here. The pattern being described by the slope is up 1 over 4, up 1 over 4. Or I could go backwards, down 1, back 4, down 1, back 4, and draw my line. Okay, that's slope-intercept form. All right. If I look at this guy, it says write in slope-intercept form and then graph, okay? Writing things in slope-intercept form is one of those things that comes up a lot. And really, anytime we want to write in slope-intercept form was y equals whatever, all right? Y equals mx plus b. So the idea here is we just solve for y, get y by itself. So right here, if I want to get rid of this 3x, I have to subtract it from each side. So I'm going to subtract the 3x from each side. And we've done this a little bit before, all right? And so now over here, I have the minus 4y still. Over here, I literally can't do the 12 and the minus 3x because one's an x and one's a number. It doesn't work that way. But now let's write it in the appropriate order. I should write the x value down first. So I'm going to leave it as a 12, a positive 12, and I'm going to leave it as a minus 3x. I'm just going to write the minus 3x first. And then I have to be very literal about that 12 being a positive 12, so a plus 12. Okay? And now I'm going to divide each side by negative 4 to undo multiplying by negative 4. I divide by negative 4. Once again, I have to use my distributive property here. So I'm going to do the negative 3 divided by negative 4. And really, that just stays as a fraction. However, negative divided by negative is a positive, so a positive 3/4. And then I have to do the 12 divided by negative 4. I'm just taking it off to the side to show my distributive property. And that's going to be a negative 3, so a minus 3. See, now I have the slope and the y-intercept. The slope this time is a 3/4. The y-intercept, the b value is negative 3, so that's the ordered pair 0, negative 3. Okay, always write it as an ordered pair. It'll save you work in the long run, I promise. 0, negative 3 is right here, and then the slope, up 3/4, up 3/4. And I could keep the pattern going the other direction, down 3, back 4. And so when you look at that and you look at the amount of work that was involved here, hopefully you're looking at that going, hey, I remember doing that example when we did the cover-up method. And if you think back when we did the x and the y-intercept, the x and the y-intercept was way easier than what we just did, okay? Writing everything in slope-intercept form, most students kind of get into that habit. They only remember slope-intercept form, so they go into this habit of always rewriting everything in slope-intercept form and only using that to graph. That's not a good idea, all right? This problem is a pain doing it this way. It's way easier if we had done this. If I'd gone, hey, let me scribble that guy out. Oh, the y-intercept, see, is a negative 3. And then scribbled this other guy out, ready? See, this is one of our previous methods, and said, hey, let's solve for x. Oh, x is a 4, so that's 4, 0. Now I can plot those 2 points, and it'll give me the same pattern, okay? So keep that in mind. You know, we're not learning the best method right now. We're learning the best method for certain situations, okay? When your equation is in that format, x value, y value equals number, using the intercepts is probably easier, and we can see how that would translate into the graph. So keep that in mind. Don't throw away those other methods just because we have something new. The new thing's not always the best thing, okay? A company selling widgets charges $3 per widget with a flat shipping fee of $5. Graph the equation, state the domain range. Now I say state the domain range. We more want to think about the domain and range, okay? So think about this as we start to plot our points here. So the company is selling widgets, charges a $3 per widget. So if I said, I don't know, x equals the number of widgets, okay? And then y would be the total price. So y equals, the price is $3 per widget, so 3x. There's that per thing again, $3 per, it's implying that it's multiplication, plus a flat shipping fee of $5. So add on another $5 to that cost. So now we can see this thing in slope-intercept form. And if I were to plot this, let's see, 1, 2, 3, 4, 5, it's right here. And then up 3/1, up 3/1, and then I could draw that. However, notice I didn't draw the line going the other way. We're thinking about domain and range. If we think about domain and range here, could I have negative widgets? Could I be charged a negative value? No. So the graph should only go in the one direction. This isn't even accurate, though. Could I buy 0 widgets? If I buy 0 widgets, am I going to be charged $5 for shipping? The answer is no. Like right here, this point doesn't make any sense. All right. So what happens is maybe I should erase this. Maybe my line should start here. So, you know, if you draw that entire line, that's okay, all right? But we want to think about this in context, all right? We want to be able to apply the things we're learning to a real situation, all right? So when you think about it, the minimum I'm going to be charged, I have to buy at least one widget. The minimum I'm going to be charged is an 8. It's right here. It's this ordered pair, 1, 8. See, this equation would probably be better to talk about in point slope form using the 0.18. And that's the kind of point I want to make here. All right, is that sometimes other formats are better. This one would make more sense if we talked about it as a starting value of 1.8 and then increasing at $3 per widget from there. Okay, so think about how we would interpret these graphs. If we look at these guys, all right, we're going to practice rewriting things in slope-intercept form, and so solving for y. So here I have one in point-slope form. Going from point-slope form to slope-intercept form is the easiest version, okay, in my opinion. So when we do this, it's just our distributive property. Ready? I'm just going to distribute that value. That's a negative 3 halves x. And then negative 3 halves times negative 4, remember, that's a division sign. So really, we're doing negative 3 times negative 4, but then also divided by 2. All right, and if you think about it that way, negative 3 times negative 4 is a positive 12, and then the fractions bar is a division sign. So 12 divided by 2 is a 6. Okay, that's what a fraction bar is. Please stop being afraid of fractions and recognize them as division symbols, okay? You can do multiplication and division. That's what that problem is asking you to do. And now let's subtract the 3 from each side. And clearly that should be done in red because that just feels right for everyone. So now I have y equals negative 3 halves x plus 3. And so now I have this thing in slope-intercept form. The y-intercept, I see the b value is 3, so the y-intercept is 0, 3. That's where I'm going to start. The slope is a negative 3 over 2, so that's describing the pattern. So I plot this guy, and then it's down 3 over 2, down 3 over 2, down 3 over 2. Going backwards is up 3, back 2. That's it. And again, if you were graphing this thing, if the directions just said graph, hopefully you wouldn't go through and put this in slope-intercept form. Hopefully you would do point slope. See right here, we can see the ordered pairs. So think about point slope form for a second. That would be the ordered pair 4, negative 3. Remember, we do those opposites. And now look at the graph. Does the graph go through 4, negative 3? I can see that point, and then I could use the slope from there. So keep that in mind. This one, same kind of thing. I'm going to distribute that too. And now to solve for y, I'm going to add the 2 to each side. Okay, so going from point slope to slope intercept is always the same 2 steps. It's always distribute and then move that last piece. Okay, so distribute and then move. So now this one, when I look at it, it's giving me a y-intercept of 8. So that's the ordered pair 0, 8. And it's giving me a slope of 2. So now I plot 0, 8. Ooh, right on the tip of my graph here. The directions that the slope is giving me is up 2 over 1, but that takes me off my graph. So let's do it backwards, would be down 2, back 1. Okay, and I could keep that pattern going. And once again, when you look at this thing, wouldn't it be better to have just done point slope form here? All right, so think about that. Think about the ordered pair that it gives me. That would be negative 3, 2. Remember, I do the opposites of those. So look at the graph. Do I have negative 3, 2 on there? Negative 3, 2 is right here. All right, it's right there in my graph, and then I could have used my slope from that point. And again, wouldn't that have been easier? All right, yeah, we want to practice slope-intercept form, and we want to practice writing things in slope-intercept form, but don't forget about those other methods, okay? Here's another one. Whoa, my screen just jumped on me a little bit. Sorry about that. So here, again, same 2 steps. I'm going to distribute. And when I distribute this guy, that's a 2/5 x minus, well, this one's not looking so good. It's saying times 2 and then divided by 5, right? So times 2 is a 4, and then divided by 5 is just going to stay as a 4 over 5, right? And now I have to add this guy to each side. Oh boy, this is getting really ugly, isn't it? Whew, you might have to take that off to the side. I believe that gives you a positive 1/5. Oh, great. And so when you look at this, this is not going to be easy to graph. This is going to be a pain. I got to start at a y-intercept to 1/5. That's the ordered pair 0, 1/5. This is awful. This isn't even working out well at all. How am I supposed to make this accurate when I'm starting at a 1/5? I don't know where that is, like here-ish? I don't know. And this graph is still so tiny, my point takes up more slots than that. And then it's up to over 5. I have no idea if this thing is accurate at all. And so I'll just draw my line and hope for the best, I guess. All right. But the point I'm trying to make here is that's not a very good method for graphing, is it? Okay. If you had thought about it the other way, point slope form, that would be 2, 1 for your ordered pair. Isn't that a nice ordered pair that you can graph? And look at that. That would be this point right here. And then couldn't I use my slope up to over 5 from there? And so luckily, I graphed mine pretty accurately, okay? But it might not have worked out that way. Down 2, back 5. Look at that. See, I was a little off on this other end. That would be a much more accurate graph if I had used point slope, okay? So keep that in mind. Same thing. Let's look at the next one. Ready? If I want to solve this thing, I've got to move that 3x. I've got to get rid of it. So I'm going to subtract 3x from each side. Once again, I cannot subtract these things, so I just write them down, negative 3x and the plus 9. And I always put the x first. And now I divide it by negative 2. Once again, this is going to be a really ugly one. After I do my distributive property, it's going to be y equals, that's a 3/2 x minus 9/2. And when you look at that, that is an awful, awful thing to try to graph. So I've got like 4.5 here for my y-intercept, all right? And notice I'm not even putting much effort into this at this point because it's not going to be accurate no matter what because of the way I'm trying to do this. But 4.5, be right about there-ish, okay? Taking a little guess. And then up 3/2, be maybe there. And then I could do it again. Okay, it's not very nice. It's not very good, but I did my best, okay? And again, when you think about this one, wouldn't it have been a lot better to do this? Hey, let's cover this guy up. Yeah, I still get the 4.5, all right? But instead of having to count off of that fraction, well, I could just do my other intercept and say, you know what? Let's go ahead and graph this other guy and say, oh, look, it's got a y-intercept, or sorry, an x-intercept of 3. That's a lot easier, 3, 0. And wouldn't it have been easier to plot those 2 points? Yeah, the negative 4.5 I still have to plot, but 3, 0 is a much nicer point. And then I could use a straight edge to graph this and look at how much more accurate my line got, okay? So again, slope-intercept form is great when it's in that format. And yeah, it's not too bad to get things in that format, but there are better methods, okay? And so when you look at these previous two, obviously that first equation would have been better to do point slope, all right? The next one, if I could spell slope, getting a little ahead of myself. Slope. The next one would have been better to use the intercepts. Okay, so using those x and y intercepts. So please understand that, depending on the format of the equation will determine which method you should use. Yeah, if y is by itself and it's y equals mx plus b, use point slope. Start with the y-intercept and then use the pattern of the slope to graph from there. But if it's in point slope form, use the point that's given and then use the pattern of the slope from there. If it's in standard form, like this last one, find the x and the y-intercept, and then use the pattern between those 2 points to come up with the rest of the points. Okay?